Hi, here we are looking at a partnership demo from NVIDIA and ArangoDB. So ArangoDB is like you can take in graph databases and bring it. So first of all, what we did is like if we go to the runtime of this particular machine, you will see if I check on this is running T4 GPU with high RAM because we would be doing a lot of stuff with NVIDIA right now. So first of all, what we did was we installed ArangoDB instance over here. Now this application uses NVIDIA SMI. We see like it has the CUDA driver. We then install the QGraph library, that is the NVIDIA open source library that's needed for graph visualization. We have installed it over here. Then we have implemented LangChain for interaction between the graph databases. Okay, so apart from that, we have also included different libraries that are needed, like to check QGraph is NetworkX QGraph compatibility is there. We may make a connection to the ArangoDB. Then we get the details of all the edges and nodes for the DB. We see like it's a protein-protein interaction data set that we have. So the nodes represent individual proteins, edges represents the interaction between these proteins, and edge attributes like it contains the confidence score identifying the strength and the quality of the interaction that has happened. Okay, so what we do is like we are creating entire synthetic data set that has been updated, and also we have like the graph has got 334 nodes and 993 edges. Now we visualize the entire graph over here. Then we persist the data into the ArangoDB database for cloud that we have. We see the nodes of it. We do a simple query to check like what are the sample nodes, sample edges, and then we have the ArangoDB instance. We initialize OpenAI over here. After that, we call in the details of the LangChain. Then we have the agentic AI application reloaded, but the most important part starts over here. So after this part, you will see like here if we go to the bottom of the tool itself, um, we would be enabling the rapids are like these are tools for different kind of applications. So here you see like we have imported local, then warnings. We get the networks QGraph implications that are there. Then we have the QGraph utility, what's there, and we make it to QGraph backend. The backend consists of the NVIDIA QGraph that's been completely hooked, so that we are using the entire GPU for this unit. Then we have the NetworkX compatibility. We see the between centrality visualization for the entire dataset that we have. Again, similarly, we get the centrality as well as PageRank visualization, but the magic happens here. Now if we change some threshold values for our tool AI agentic tools, we can visualize the PageRank and also associate different protein values over here associated. So this is the interaction between the proteins that is happening. Then we have the proteins with greater degree of 2. If we change this value from 2 to 3, you can see the results right away. Just wait for it to come. You see it for 3, where we have the we have proteins with degree greater than 3. We see the values of it. Now after that, we have the Matplotlib line. Now after this, if we focus on certain path, like we have calculate the between centrality of the entire data set that's there using QGraph. Then again, this is for a small greater than select the proteins with degree greater than 5. We have to find out biomarkers too for the proteins. Okay, so we have used another tool to find a biomarker. So if you'll see like now, we get the biomarker like this, and after that we also get the layout as a circular. We get the biomarker for that. Then we have an entire solution flow that gets interaction between the path, and also we get the different kind of visualization for different kind of graphs that we have. So if we choose it to be spring layout, this comes to be like this. This is the shortest path that we are finding between protein 10 and protein 25. Then we have the Kamada Kawai graph, that's their layout that's being used for the analyzing signal pathway. Finally, we get the analyzing signal pathway for a circular graph. Okay, so I've used a lot of utilities for this, and finally we can also see like how the community detection visualization happens between different set of proteins. And if we see, like if you want to check for the select proteins that are greater than values of 5 for the community detection, you see that also. So it's a complete application, open source application made with the help of QGraph, uh, NVIDIA Rapids for initializing the entire backend for the QGraph that we have used, and it was a very good experience. Thank you.